Integration by substitution with trigonometric functions. So, if your main function is of the form sine of f of x or cosine of f of x, we want to isolate the inside function f of x and determine if the derivative of that function is also present in the problem. If it is, then your problem is a good candidate for integration by substitution. Example 13. So notice here that we have a cosine within our problem, and we notice that inside the cosine is something more complicated than just an x. So here we consider the function that's inside cosine, which is x squared plus 4x minus 6. The derivative of that function is 2x plus 4. We notice that 2x plus 4 is also part of our integral. So this is a good candidate for integration by substitution. So when we do integration by substitution with either a sine or a cosine function, the way we pick our u is going to be the function that's inside the trig function. So here, my u is going to be the function that's inside cosine. So that's x squared plus 4x minus 6. So du dx, the derivative of that, is 2x plus 4. So my du is 2x plus 4 dx. So now I want to plug things in terms of u to see if I can get it in the form where I can take the antiderivative using my antiderivative chart. So again, what I'm going to do first is substitute in my u. So we said that u was going to be the function inside of cosine. So we have cosine of u. Now we want to look at what's left on the outside. So we have a 2x plus 4 dx. So we come over to our du and we compare it to that. My du is 2x plus 4 dx. So it's an exact match. So that means instead of 2x plus 4 dx, I can substitute in a du. So now my problem has become find the antiderivative of cosine of u du. The antiderivative of cosine is one from our chart, and the antiderivative of cosine is sine. So that means that the antiderivative here is sine of u. But I don't want u in my final answer, so I have to substitute back in what u represents. So here, I have sine of x squared plus 4x minus 6 plus c. So I want to point out a couple of things here. First, I picked my u by looking for the function inside the trig function. The u itself didn't include the cosine. It only included the function inside the cosine. Second, here, when I went from the antiderivative of cosine du, I dropped the integral symbol in the du because those were operators, and once I actually found the antiderivative, I didn't need them anymore. So you don't continue representing them with the integral and the du once you've actually found the antiderivative. Let's look at another example. Notice here that I have an e to the x function. Now, e to the x is its own integration by substitution problem. However, when we do an exponential substitution problem, the difference is that the power of the exponential is going to be a function in itself, something more than just x. So if you see an e to the x in a problem, but it's just e to the x, that's not the main function. So that's not what we're observing to do our u substitution. What I notice here is that I have sine of something complicated, which means sine is my main outside function. Therefore, I know I'm doing a trigonometric integration by substitution. So again, I'm going to pick my u to be the function inside of the trig function. So here that's e to the x plus ln x. The derivative of that is e to the x plus 1 over x, which means my du is e to the x plus 1 over x dx. So now I have my u and I have my du. So I want to try to match it up so that I can do my substitution. So my u, again, was the function inside of sine. So I'm going to rewrite that as sine of u. And then I look at what's left. E to the x plus 1 over x and dx. If I look at my du, that's exactly what my du is. E to the x plus 1 over x dx, which means I can substitute that directly in. So sine of u du. So now I have the antiderivative of sine of u du. The antiderivative of sine is going to be negative cosine. So here I get negative cosine of u, but I don't want u in my final answer. So I have negative cosine, now I substitute back in, of e to the x plus the natural log of x. So here I can see that I have my antiderivative, and again, I found it using substitution. Again, I knew that my main function was a trig function because the inside of the sine function was something complicated. That helped tip me off that that was the main function. Let's look at another example. Example 15. So here, I notice that I have parentheses, but I also have cosine of something complicated. So since I have cosine of something complicated, I'm thinking that my substitution will be based on trigonometric functions. So I'm going to check my u and my du to make sure I can continue using substitution in this way. So since cosine I'm assuming is my main function here, my u is going to be whatever is inside that function. So x cubed plus x to the sixth. So now my derivative of that is 3x squared plus 6x to the fifth. So my du is 3x squared plus 6x to the fifth dx. So now, when I start to do my substitution, I first start by substituting in my u. So I have cosine of u. Then I want to look at what's left. So what's left is an x squared plus 2x to the fifth. I notice that my du has an x squared and an x to the fifth, but my constant is a little bit different. So I need to figure out how to manipulate my constant to make it match. So if I factor out a 3 here, I'm left with an x squared plus 2x to the fifth dx, and that matches what I need. So that means I need to divide both sides by 3 to isolate the term on the right to match what's in my antiderivative. So I have 1/3 du equals x squared plus 2x to the fifth dx. So now what's on my right hand side matches exactly what's in my antiderivative. So here I can substitute in a 1/3 du. So 1/3 du is going to go in here. I like to pull my constants out front. So I pull the 1/3 out front and I get cosine of u du. So now I have my constant multiple, which is 1/3. This indefinite integral says find the antiderivative of cosine of u du. So to find the antiderivative, I need to find the antiderivative of cosine, which is going to be sine. So I have 1/3 sine u. I don't want a u in my final answer, so I have 1/3 sine of x cubed plus x to the sixth. So as you may start to notice, if our main function is a sine or a cosine, we end up with a sine or a cosine when we solve for our final antiderivative, because these are antiderivatives of one another. It's what's inside that makes it complicated. So that's why we need to do our substitution to make sure that we're carefully representing all the things that are happening on the inside. Let's try one more. So here, we have to be a little bit careful about what we're seeing and what is the inside and outside function. So notice that we have a sine x here, and this is sine of cosine of x. So sine of cosine of x is the more complicated function, with sine being the outside function and cosine being the inside function. If you think back to the other problems we did, our u was always the inside function that was plugged into the trig function. So here, that means my u is going to be cosine of x. So the derivative of cosine is negative sine. So du is negative sine x dx. So let's be really careful here. We're going to start by substituting in our u. So the u is going into this sine function here. So sine of u. When we look at what's left, we have 6 sine x dx. Our du is negative sine x dx. So they're close, but they're not quite the same. However, they're related by a constant, so I can still work with this. So in order to have 6 sine x dx, I need to multiply both sides by negative 6. Because if I multiply negative 6 times negative sine, the negatives will cancel, and I'll get 6 sine x dx. And that's what's in the indefinite integral. So now that we have it matched up, and we have on the right-hand side what we need to plug in, I know that I can substitute in a negative 6 du. I'm going to put my negative 6 in front because I like my constants in front. The constant multiple rule says that the negative 6 will multiply the antiderivative of sine u du. So remember, the antiderivative of sine is negative cosine. So we have negative cosine of u. So here again, we took the step where we found the antiderivative, so we no longer need the integral symbol or the du. We don't want a u in our final answer, so we want to plug back in. But I also noticed that I have a negative 6 times a negative cosine. So that means the negatives are going to cancel out. So that leaves me with 6 cosine. Now remember, my u is also cosine. So I have 6 cosine of cosine x. It's a little strange to have trig functions embedded in one another, but as long as we're careful with the process, we can carefully solve and come up with the correct antiderivative for this function. And remember, if we were to take the derivative of 6 cosine of cosine x, we should get back what we started with of 6 sine times sine of cosine x dx.